So how will you integrate tan x, tan 2x, tan 3x? So I assume let I is equal to this integral. Okay. Now this is a very special kind of sum, which if you see, no substitution can actually do this, can actually work here. Okay, because if you substitute anything like t is equal to tan x, or t is equal to tan 2x, or t is equal to tan 3x, you will not get anything. So, but what you see here is that you have a product of tan x, tan 2x, tan 3x. So this is a special kind of sum. Try to remember this technique. If you remember the triple angle formula before starting with the sum, if you remember the triple angle formula, tan a plus b plus c. So what you do here is you write tan a as x, b as 2x, and c as 3x. What will you get? You will get tan a plus tan b plus tan c minus tan a, tan b, tan c divided by 1 minus tan a, tan b minus tan b, tan c minus tan c, tan a. This is what you get, right? So if you
Yes,
see
sir.
this product here, tan x, tan 2x, tan 3x, you have this product here, isn't it? This is the product that we need to find. So what will you get in the next step? In the next step, you will get tan. Now x plus 2x plus 3x is 6x. So tan 6x is tan x plus tan 2x plus tan 3x minus um, minus tan x, tan 2x, tan 3x divided by 1 minus tan x, tan 2x. Just give me a minute. Or better still, you break this up as, instead of doing all this, okay, just uh, so you break this up as, you have tan 3x is equal to, you start with tan 3x. Okay, tan 3x is tan x plus 2x. See, why did I break up this way? Because see, I have a 3x, I have a 2x, and I have a x here. See, I'm getting a 2x, I'm getting an x, and I also have a 3x. That is why I'm breaking it up this way. Why? What are the benefits? You will see in the following step.
Okay,
You
sir.
can write this as tan a plus b. Tan
Yes,
a
sir.
plus b is, by compound angle formula, tan a plus tan b
Yes, sir. Yes, sir.
by 1 minus tan a tan b. Okay. So what are you getting? You're getting tan 3x is equal to this, right? So that means if you now cross multiply, what will you get? Tan 3x into 1 minus tan x, tan 2x is equal to tan x plus tan 2x.
Yes, sir.
That means tan 3x minus tan x, tan 2x, tan 3x will be equal to tan x plus tan 2x. Okay. So what will you get here?
Yes,
See,
sir.
you are getting tan x, tan 2x, tan 3x here. You will find out this value. So therefore,
Yes, sir.
tan x, tan 2x, tan 3x will be tan 3x minus tan x minus tan 2x, right? So therefore, you see you have
Yes,
got
sir.
the value of tan x, tan 2x, tan 3x as a sum of three tans. Now this will be
Yes, sir.
now this can be easily integrated. Therefore, I is equal to integral tan x, tan 2x, tan 3x dx must be equal to integral of tan 3x minus tan x minus tan 2x dx, right? Now you can
Yes, sir.
separate integral tan 3x dx minus integral tan x dx minus integral tan 2x dx. Okay. Now tan 3x, what is the integration of tan x? It is log sec x, right? But you have 3x here, so it is log sec 3x.
Yes, sir.
But because it is 3x, I will divide it also by the derivative of 3x, which is 3. This is simply log sec x, and this is similarly log sec 2x divided by derivative of 2x. Okay, that's it. That is your required integration.
Yes, sir.
Yes, sir.
Yes, sir.
And finally, you have number 7. Number 7 is integral tan cube x. Okay, now this is an important sum, tan cube x. Now see, you know that the derivative of tan is what? Sec square. And you also know that tan is related to sec square as sec square theta is equal to 1 plus tan square theta. We'll make use of these two. Okay, what you will do here is, you first, since you know that the derivative of tan x is sec square, you write tan cube x as tan square x into tan x.
Yes, sir.
Okay, now what you do here is that you know that derivative of tan x is sec square, so you write tan square x as sec square x minus 1 to tan x
Mm,
dx. Okay, now what you do is you separate the two integrals. You get, or you multiply everything with tan x, you get sec square x tan x dx minus integral tan x dx. I can write it this way. I have multiplied and separated the two integrals, right?
Yes, sir.
Now what you do is you call this I1 and you call this I2. Okay, we'll integrate the two separately and then we'll calculate I. So here, what is I1? I1 is integral sec square x tan x dx. Okay, so you know that the derivative of tan x is sec square. So you put t is equal to tan x. So what do you get? dt dx is equal to sec square x. That means you get dt is equal to sec square x dx. So you see that this sec square and this dx, this they combine to give you a dt, and this tan x is simply t. So this you getting t dt simply. What do you get here? Half t square integration plus a constant. And what is the value of t here? We have taken t to be tan x. So this is half of tan square x.
so tan square
X. Let us call this constant c1.
x plus.
Okay,
Yes, sir.
because we have a
Yes, sir. C1.
second integral to integrate also. Also
Yes, sir.
I2 is integral I2 is integral tan x. This is a standard integral I2 tan x dx. And you know that integral tan x is log sec x, standard formula, plus let's say C2. Okay. So therefore, what is I? I was I1 minus I2, right?
Yes, sir.
And I1 we have got this as half tan square x. Don't write the constant. Okay. C1 and C2
Okay,
constant
sir.
will merge to form a single constant C. Okay. And you have I2 as log sec x. And these two constants, C1 and C2, we actually merge actually. Okay. You write C1 plus C2. But instead of writing C1 plus C2, you simply write a single C, because you don't want the value of the constant. Constant is always a constant. Okay. Whether C1 plus C2 or C1 into C2 or C1 divided by C2, whatever, constant will remain a constant. So when you're adding two
Sir,
constants, yes,
sir, the constant C1 and C2, it will be C1 minus C2, no?
yeah, whatever, C1
Because
minus C2.
I want
Yes, tell
yes,
me.
sir. Sir, because I1 minus I2 is there, so then constant will be C1 minus C2, or
Yes,
simply we will take as C constant.
simply you take as C, because it will be C1 minus C2 here. It will be
Okay,
C1
sir.
minus C2. But the point is whether two constants are there, whether C1 C2 will also be a constant. C1 by C2 will also be a constant,
Yes, sir.
isn't it? C1 minus C2 will also be a constant, or C1 plus C2
Yes,
will
sir.
also be a constant. You are not bothered about the value of the constant. You simply want to see whether it is a constant or not. So whether you write C1 minus C2 or you simply write a C, it will not make any difference. You can write a plus C
Okay,
here,
sir.
because C1 and C2, C1 minus C2, they merge to become a single constant. Okay. We are not concerned about the value of the constant here. Even if you get a
Okay,
product
sir.
of constant, it is still a constant. Okay. I
Okay,
think
sir.
substitution method is over. Okay. Let us now start with
Okay.
integration by parts. Okay. The fundamentals. Now, what do you mean by
Okay,
integration
sir.
by parts? Integration by parts. Now, what is integration by parts? You know that the sum of the integral is, we know that if u and v are functions of x, then now if you remember, in derivative we had ddx plus ddx of u plus v is equal to du dx plus dv dx, right? So we have a rule of
Yes, sir.
addition rule in differentiation. ddx of u into v, you had a u
Yes,
into
sir.
v rule, right? ddx of u by v, you had a u by v rule in differentiation. Similarly, in integration, we have, we already know that integration u plus v dx. How do you do this, evaluate this integral? You take the individual integrals, right? Integral u dx plus integral v dx, isn't it? Or even if there is a minus sign, you take a minus sign, isn't it? But what if I tell you how to take the product rule for integration? If I give you the product of two functions, u into v dx, then how will you integrate this? That is the question here. Understood? For differentiation, you had a u into v rule, right? If you remember,
Yes, sir.
ddx of u into v, you had what? U dv dx plus v du dx, right?
Yes, sir.
Similarly, for integration, we have a product rule. We don't have a quotient rule for integration. Okay. We don't have this integral
Okay,
u by v dx. We don't have.
okay, sir.
Okay. We don't have this. We only have
Okay,
a
sir.
u into v rule for integration. Okay.
Okay, sir.
So integral u into v dx. How will you evaluate this integral? Remember this formula. This is called integration by parts. This rule here, u into v rule for integration, is called integration
Okay,
by
sir.
parts. Okay, this is called integration by parts. How will you remember this formula? You will take the first. U is called the first function. We call this as the first function, and we call as the second function. Okay, first function you take. You remember it in this way. First function. Remember this statement. Okay, first function into the integral of the second function. Okay, minus
Yes, sir.
integral of derivative of first function into the integral of the second function. Okay, you remember this formula in this way. So what is the formula for integral u into v? It is first function into the integral of the second minus integral of everything within the curly brackets. And what is within the curly brackets? Derivative of the first function into the integral of the second function. So mathematically, how do we write this? Here u is our first function. So write u integral of second function. V is our second function. V dx minus integral of derivative of first function. The first function is u. What is the derivative of u? Du dx. Okay, and you put a curly brackets
Yes,
here
sir.
Yes, sir.
into the integral of the second function, that is v dx, and whole thing has to be integrated dx. Understood? Please remember this
Yes, sir.
formula
Yes, sir.
by heart. First function into the integral of the second minus integral of derivative of the first into the integral of the second. Now let us see a very simple example to start with. Okay, how to apply integration by parts. Let us say I have to evaluate x e to the power of x dx. How do you um, evaluate this integral? If you see, this is a product of two functions, right? X and e to the power of x. So this is my u and this is my v. Now remember, there is a actually not a rule. Okay, this is not actually a rule, but if it will be easier if you take your choice of first and second function in this way. Isolate. Isolate. What does this mean? This means inverse functions, inverse circular functions. Okay,
Yes,
this
sir.
means
Yes, sir.
logarithmic functions. This means algebraic functions. This means trigonometric functions.
Trigonometry.
And this means
Yes, sir.
exponential functions. This isolate rule will help
Yes.
you decide which function to take as u, which function to take as v. Okay, now in this example that I have given you, x e to the power of x, if you see, you have this as an algebraic function and this
Yes,
as an
sir.
exponential function. So this is a product of
Yes.
algebraic and exponential function. Now if you see, exponential function is here
Yes.
and algebraic function is here, and a comes what? A
Yes.
comes before e, right?
Yes, sir.
Since a comes before e, therefore this will be our first function. That is, you take this
Yes.
as your u and this as your v, right? So in this, because of the
Yes, sir.
isolate rule, what I'll do here is that I will take my algebraic function, this as my u, as my first function, and this as my second function, v. And now I'll integrate. Remember, the decision of u and v is very important. Okay, which one you're taking as the first function, which one you're taking as the second function. Your choice of first and second function is very important. That is the choice of u and v. So now let us integrate by parts rule. First function is u. Put it, okay, according to the formula. Integral of the second function is v, e to the power of x, right? Minus integral of the derivative of the first. What is the derivative? What is the first function? X. So ddx of x into the integral of the second. Second function is e to the power of x dx, and whole thing has to be within dx. Check with the formula whether you understood or not.
Mm, yes, sir. Yeah.
Amir,
Yes, sir.
you understood?
Yes, sir.
Okay. So now let us do the evaluation part. X. What is the integral of e to the power of x? It is e to the power of x minus integral of derivative of x. ddx of x, you know, is 1, and into
Yes, sir.
integral of the second. What is the integral of e to the power of x? It is e to the power of x dx. Right? This is the second step. Any problem in understanding the second step?
No.
Okay.
X e to the power of x. Now in minus integral e to the power of x into 1 is simply e to the power of x dx. So this is x e to the power of x, and you know integral e to the power of x is also e to the power of x plus constants, and this is done. Now what you can do is you can take e to the power of x common and write this as x minus 1 plus c. Understood? This is
Yes,
the
sir.
this is the most simple kind of integration by parts problem that you can come across. Okay. Uh, Let us take another example of x cos x. Let's say example 2. Again, you assume let I is equal to integral x cos x dx. Now, which one should you take as your first function? Which one should you take as a second function? Again, isolate rule. This is a product of what? An algebraic function and a trigonometric function. And a algebraic
Yes,
function
sir.
occurs before uh, a occurs before your t, right?
Yes,
So
sir.
therefore, the algebraic
Yes,
function,
sir.
this will be my u, and this will be my v.
B. Yes, sir.
So according to the formula again, first function into the integral of the second
Integration of cos x dx
minus
minus
integral of the derivative
integral
of
of x. Yes, sir.
x into the integral of cos x
Minus
dx, and whole thing has to be integrated, right? From the formula, of by
Yes, sir.
parts. Now what is the integration of cos x? It is sin x. So x integral cos x means x sin x minus integral of derivative of ddx of x is what? 1,
one
and again integral cos x is sin x.
sin
Yes.
x.
So what does it become? It becomes x sin x minus integral sin x dx. So this becomes x sin x, and what is the integral of sin x? It is minus cos x plus c. This is done. So this is x sin
Yes, sir.
x
Yes, sir.
plus cos x plus c. This is your answer. Okay, let us take another example here. Example 3. Let I is equal to integral of x square sine 2x dx. Again, algebraic and trigonometric. So algebraic has to be the first function. So I can write this as first function into the integral of the second minus integral of derivative of the first into the integral of the second, and whole dx. Right? Do this step by
Yes, sir.
step, otherwise you will make mistakes. Okay. So first function
Okay,
x
sir.
square, and integral of sine 2x, you know, is minus cos 2 minus half cos 2x or minus cos 2x by 2, right? You know the integral of cos
Yes,
sine 2x
Yes, sir.
minus integral. Now ddx of x square is what? 2x, and integral sine 2x is again
So minus what?
minus half cos 2x. So write this as
Yes,
minus
sir.
half cos 2x and whole thing dx. Now what happens? This 2 and this 2, they cancel. So what do you get? Minus half x square cos 2x, and these two minus signs here, minus this minus, they combine to become a plus. You get integral x cos 2x dx, right? Now since you're getting x cos 2x dx, again this has to be, you have to apply by parts. So minus half x square cos 2x, and this again you apply by parts. What is the formula again? Again, this is a product of algebraic function and a trigonometric function. So algebraic function has to be the first function into the integral of the second, minus integral of derivative of the first into the integral of the second. I will do dx. Okay, so minus half x square cos 2x plus, now what will this be? What is the integration of cos 2x? It is half sine 2x. This will become x by 2 sine 2x minus integral of ddx of x is 1, and integral cos 2x is how much? Again, half sine
Yes, sir. Half
2x
minus
dx.
sine.
Okay,
Yes, sir.
so this will become minus half x square cos 2x plus x by 2 sine 2x, and half is a constant, you can take it out, minus half integral sine 2x dx is equal to minus half x square cos 2x plus x by 2 sine 2x minus half, and integral of sine 2x is how much? Minus half cos 2x, or minus cos 2x by 2, right? Plus
This, sir.
constant. So this is done. Minus half x square cos 2x.
Sir, we can take half as common.
You can, in the next step, you can do a lot of simplifications if you want. Okay, plus 1/4
Okay, sir.
cos 2x plus c. What you can do here is, but no point simplifying actually. But what you can, if you want to simplify, what you can do is, you can take 1/4 common. Let's take minus 1/4 common to keep the first term positive. Minus 1/4, if you take common, what are you going to get? You're going to get 2x square cos 2x,
Okay, sir.
right? Plus 2x sine 2x. In fact, minus sine 2x. This should be minus because we are taking a minus sign outside. So this sign changes from plus to a minus. So minus 2x sine 2x plus cos. In fact, this plus will also change to minus
Sir, it will be minus.
cos 2x plus a constant. That is what you can do. Okay, but no point doing this step.
Yes, sir.
You do till this step and it's okay. You don't need anything. You will not achieve anything special by doing this step. This is just a stylized way of writing. Okay, so
Okay, sir.
uh, I think I'll stop here for today. Okay,